Hello? Am I audible? Hi, sir. Yes, sir, you're audible. Okay. But nobody's name is displayed. That's why I'm worried. Only some symbols are displayed. Maybe it should be okay.
Good evening, one and all present here. Greetings from IGS Student Chapter, Marine Engineering College. It gives me immense pleasure to in climatic situation. We have planned to conduct this webinar online, hoping all your support and cooperation throughout the session. For today's session, we have Sreekanth APV, Executive Director of Arcadis, on the topic Engineering the Future, Industry Overview, Civil Engineering in Next 30 Years. So before moving on to the session, it's time to address the gathering. As the head of the department, Dr. Vinod P. is having an emergency. We couldn't have him for attending the session. So now I invite Dr. Narayanan S., Professor of Civil Department, to propose the welcome speech. Over to you, sir.
Thank you. Yeah. Very good morning to all of you. It is my pleasant duty to welcome the guest to this webinar, Mr. Sreekanth APV. In the name of the management of the college, Principal Professor Ruby Abraham, Directors, Head of the Department, and on my own behalf, it's my pleasant duty to welcome Mr. Sreekanth APV. Actually, I was just reflecting back on 1 year back, you gave a talk on professional excellence. On professional excellence, it was well received, and now you are going to share your experiences in another area, that is what the future holds for the students. And looking at your curriculum CV, I find that you have a truly global experience in learning as well as in experience. A graduate of CET, Masters from NUS Singapore, and Executive MBA, University of New York. Truly great experience in learning, and looking at the professional experience also, it is great to see the experiences being the country head of a truly global company. That is executive director of Arcadis, one of the largest global consultancy companies in the world. I think it is we are fortunate and our pleasure to have you with us to share your experiences. The students will greatly benefit from that. So, without much ado, I'm not standing between you and the students. I welcome you to this meeting and to share your experience. Thank you.
Thank you, sir. Now I invite Ashwati from MTech to deliver a brief introduction about today's speaker.
Hello, am I audible? Hello?
Yes, Ashwati, you're audible.
Okay. Good evening, everyone, and welcome to the session. The opportunity of introducing the speaker is a great privilege. I would like to introduce today's speaker, Mr. Sreekanth APV. He is an executive director of Arcadis, one of the largest global consultancy business in the world. He oversees the business in India and heads the infrastructure business in Singapore. He graduated from CET Trivandrum and holds a master's degree in engineering from National University of Singapore and an executive MBA from State University of New York. Mr. Sreekanth specialized in the engineering management of large projects covering resource, transport, industrial, and urban infrastructure. He has held project leadership positions for such projects in Singapore, India, Middle East, and Australia. He aspires to play a leading role in the transformation of infrastructure in Asia. Sir, it's a great honor to hear from you this evening and truly believe that your experience can inspire young minds today. We are very glad to have you with us. On behalf of all present today, I welcome you to lead the session. Thank you.
Thank you, Ashwati. So before moving on to the session, let me just brief in some general instructions for the participants. All participants are requested to mute their microphones and switch off their camera during the session. All your doubts and queries shall be cleared at the end of the session. Please feel free to ask either through the chat box or by unmuting yourself. At the end of the session, a feedback form link will be circulated through the chat box. Please do fill it without any fail, as the certificates will be issued based on this. So, the waiting is over. Sir, the session is all yours.
Hello, good evening, everyone. Can you hear me?
Yes, sir, you are audible.
Okay, so thank you for the warm words, Dr. Narayanan. And sorry, I missed the name of the ma'am also who did the welcome speech. So thank you very much for your kind words. Yes, I still remember being in your college. I think it was in 2019. It seems to be in another world, another time when that happened, when we were all free to travel. I sort of counted the number of times I landed in Trivandrum in 2019. So in 1 year, I landed around 34 times. And since 2020 March, we have been holed up at our homes here in Singapore and in India, not being able to travel. And it is in that context that today we look at the future. So an extremely pleasant memory for me to be that I came to your college and met your vibrant student and faculty community there. My sincere thanks to Dr. Rani for arranging this opportunity for me to have this interaction with the students. So let me share my screen. Are you able to see my screen?
Yes, sir.
Okay, so today we are going to look at the future, the next 30 years. So why 30 years? Why not 50 years? Why not 60 years or 20 years? Because I graduated in 1992 and, this year, end of this year would be 30 years since we graduated. And when we look back from where we are, the change that happened over the next 30 years looks quite pale when compared to what could happen in the next 30 years. So that's why I choose to talk about the next 30 years. So I would like to cover three topics today. One is the emerging trends that we see in the, globally in the industry. How much of that is applicable to India, to a student community? Is Kerala is something that maybe you could evaluate, but these are clearly emerging trends. I would also like to talk about how opportunities would evolve, mostly in the near terms. It is very difficult to talk about 30 years of opportunities, but in the near term, how things could happen. And then we could also have question and answers session. So what are emerging trends? So I told you that when I graduated from College of Engineering Trivandrum in 1992, I thought of, look, what were the emerging trends at that time? So one, in 1992, we were sort of having started to have computers in the department. There was a computer lab, and we, for the first time, felt the entry of computers into our industry. As students, we learned a bit of programming. There was one paper on programming, but that was it. The distance from writing a paper on programming to necessarily using computers was substantial. We also saw, when we started engineering, studying engineering, we used to go to college with a T scale, and we used to spend substantial time on drawing boards. I don't know now, but those days the lecture halls used to have, drawing halls used to have drawing boards set up that 60 or 80 students could sit down, could be in a room together drawing, attending training on how to draw, how to understand. But one of the emerging trends that we saw at that time was the introduction of CAD. Okay, CAD had started to come in. Okay. I still remember visiting the computer lab with our lecturer at that time, and he showing us some basic fundamental analysis happening at that time. We used to learn Canny's method, moment distribution, different kind of structural analysis that we used to do, calculations, metric structures of analysis, all, heavy hand calculation or calculator-based calculations. But, rudimentary analysis softwares, FEM analysis softwares, we were seeing, FEM being done on elements, simpler elements, plates, shells, to, so those were the emerging trends of the days that when I graduated. And today, when I look at where those trends ended or where they are now, as of now, you can see that the CAD world has completely displaced the drawing world. It is, so that there is no more. You don't even get to buy drawing pens these days. So the drawing boards and the T scales have disappeared. Okay. Knowing, indent structural analysis methods have also become sort of obsolete. There are very good softwares available now that has completely replaced the need for having a structural engineer or a civil engineer who is good in the arithmetic calculation part of analysis. Okay. The engineering fundamentals, the knowledge of engineering, the deep understanding of load paths, all these things still matters, because we still have software. You put in garbage, you get garbage out. So the quality of inputs do matter. So you could see how analysis softwares have evolved, that it has completely made the arithmetic ability of engineers more and more obsolete. Then the third is FEM. So in FEM, what started as a trend then has now evolved into very complex analysis capabilities. Currently, we are able to do finite element modeling on all sort of things. We can do on fluids. We can do on air circulation. We can do how fire spreads. And based on those analysis, we could actually do very refined performance-based analysis. So we can see how these trends, those emerging trends in the 90s have changed. So if there were 3 or 4 emerging trends at that time, now we are looking at many emerging trends, and they are more substantial, they are more deep-reaching in my opinion. So let us look at some of these emerging trends. What I want to also maybe highlight to you that a lot of these trends might appear very high level, might appear as may not be relevant to you, or may not substantially impacting you now. But remember that these are emerging trends. In 30 years, in 2051, as professionals at the pinnacle of your career, I believe that these things would matter to you very, very substantially. So with that introduction, let me start on to the first trend. So the first trend I want to introduce is that sustainability is going to be at the heart of everything that we do. In politics, in governance, in policies, in projects, in engineering, in everything, sustainability is going to be increasingly put at the core of what we do. It is because our population is headed towards 9 billion. Our GDP is estimated to be, moving from 120 to 400 trillion in this 30 years. Energy, sanitation, housing, and resource demands are going to substantially impact us. So these trends are going to just one minute. Okay, are going to create many challenges in front of us. Now we are seeing, sorry, 1 minute. Yeah. So now we are seeing one of the impacts, which is COVID-19. There could be more waves heading our direction. There could be economic recessions. There is climate change going to happen. There is biodiversity collapse that could happen. So in the next generation of professionals, whichever field they are, and more importantly in engineering, and very particularly for civil engineering, protecting the planet will become an integral part of your profession in everything that you do. You may not feel it much now, but the UN goals of sustainable development will become more and more embedded in whatever you do. So to understand sustainability better, I want to introduce these themes of sustainability. So the first theme is energy and carbon. So this theme is about reducing carbon emissions and energy use, because these carbon and energy use are directly influencing greenhouse emissions. And it is very important that we understand, the direct, indirect, and embodied carbon in the activities that we do. The second is climatic adaptation. In the last few years, the population in Kerala has been impacted by series of floods, change in rainfall patterns, and across the world this is happening. I was reading in the newspaper that the Shangamugam beach has disappeared. It used to be one of our favorite hangouts, but we are going to see disappearance of beaches, changes in coastlines, longer droughts. The third element is circularity. So circularity is going to be how we prevent or reduce or minimize using new cycles of materials. So can we, improve efficiency in resources, in water? Can we reduce waste? Can we recycle? Can we use materials that have low carbon footprint? Can we use bio-based materials where they are by design embedded with circularity? Then it is about nature and biodiversity. So it is becoming more and more uh, important to preserve biodiversity. So in the activities that we do, whether as in profession, and especially as civil engineers, it is going to be important to understand how nature and biodiversity are impacted by your activities. Finally, societal impact. So we have talked about the impact on various elements of the planet, and it also involves the society. How does societal impact come along in our activities? So we can look at some of this in detail. So let us look at carbon and energy. Okay. So this is a map that shows from the source how our human activity changes fossil fuels and other kind of fuels into greenhouse gases. And you can see that 17% of that contribution is going to come from buildings, and around 16% comes from transport. So together, 33% of greenhouse gas emissions comes from activities that we are involved as engineers, as civil engineers. Okay, industry also contributes, but our contribution to greenhouse gas emission is substantial. So let us look at what this means. Okay, so let us look at the carbon footprint of highways. So as engineers today, you learn how to design highways, how to design the geotechnical factors of highways. But as the next 30 years evolve, it will be very important for you to understand how carbon footprint of each of your projects also matters. So when you look at a particular highway, you can see how the carbon footprint varies across the design phase, the construction phase, the use phase, and the demolishing phase. And you can see that however efficient you construct, it is the usage that in a highway creates most of its carbon footprint. So how do you resolve it? You basically resolve it by changing from fossil fuel driven propulsion to maybe other kinds of propulsions that don't contribute to carbon. Then it will substantially reduce the carbon footprint of a highway. Let us look at the carbon footprint of a building. So here you could see the red line, which is the embodied carbon. So this is the carbon footprint that is created when you build a building, through the materials, through the construction activity. You can't change much of it. It almost remains a constant through its lifetime. But then the operating carbon footprint changes. So in a low efficiency building, because of the lighting, because of the air conditioning, the energy usage continues to increase during the lifetime. As the efficiency of the building increases, it is possible to therefore make buildings more and more energy efficient. And optimize the embodied carbon of materials become increasingly important. Okay, so you can bring down the operating carbon footprint and try to match it to the embodied carbon, and then try to reduce both of it. So these are the kind of engineering activities that are going to be more and more important as we move along. Now let us look at this chart for a minute. This chart shows the temperature recorded over from 1850 to 2018 across the 12 months of the year. So as you watch this graphic, you see that the trend is very clear. Okay, our global temperatures are increasing. Across the year, they are increasing. All right. What does that mean? Okay, here comes climatic adaptation. So because of greenhouse effects, sea levels are going to rise across the world. This is not just in India or Singapore or any specific country. It is going to happen globally. Okay. Then along with that, we are going to have changes in rainfall patterns, which means the drainage paths would change. There would be more pressure on surface drainage systems to cope with this change in rainfall patterns. So if you look at the picture below, this is the map of Singapore. And in 2050, okay, Singapore is doing some studies, and what it shows is that the red areas are going to be the areas that are going to be impacted by rising sea levels. Okay, so these areas are going to be inundated, and all these areas are prime economic centers. There are the world's largest ports over here, the world's largest refinery outside of Middle East. There is the airports. There are various other kind of assets that are impacted. So this is a very serious and substantial impact, not just for Singapore. If you look at most of our economic centers across the world, they are all next to waterways. They are all next to sea or rivers, and all of them will be seriously impacted. This picture is what would happen for a small portion of Kerala. So you can see this is the Kutanadu region of Kerala and how this area would be impacted. And who is going to mitigate this risk? It's going to be civil engineers. So coastal engineering, hydrodynamic modeling, drainage designs, urban planning skills all need to come together to build resilient cities and communities. So this is going to be an important part of our profession in the next 30 years. Next comes nature and biodiversity. So this is more, we might have an impression that this is more general in nature. But we find that construction is one of the three sectors that is most dependent on nature. Most of our materials come from nature. We sort of re-engineer nature's assets for human beings' use. So that is why it is very important that our industry considers nature and biodiversity in its future. There is a very powerful slide that, this one that you see, that shows what impact we could make. So if we take the path that we have been from the past, it is going into a future where we are going to have less and less biodiversity. And that is going to be a bleak future for us. With conservation effort, we could improve it into a more positive direction. But with more, increased conservation effort, more sustainable production, more sustainable consumption, we think that it is possible to pull the curve back and even head it to a more sustainable and biodiversifying direction. So here again, engineering would become very important. So these are trends that we see now evolving, and in your future as engineers, you would find that more and more of biodiversity coming into your engineering profession. Now, societal impact. We talked about various aspects. When it comes to societal impact, thanks to the various movements that has happened in India and across the globe, societal impact have started coming into our projects in a more substantial manner. So today there are methodologies built around how societal impact and risk and opportunities need to be managed. The pandemic has, further unveiled the significance of this. Currently, investors have started considering societal impact as a very major part of their financing decision. And it is important today to, the role I see for engineers is most of the societal impacts are intangible in nature. So it is engineering that could play a part in changing this into a more tangible impact. In assessing this impact into tangible numbers that becomes decision making and investment decisions easier. So we are also seeing the trend where business value of societal impact come from brand differentiation. When Nike and Adidas were found to use use labor from Thailand and Vietnam in a negative manner, their brand equity fell. So today businesses consider societal impact in a very serious sense. Even supply chain is getting a lot of attention now. So today companies look at the social sustainability of their supply chain. The one that I talked about, Nike and Adidas, are good examples. The SDG commitments, all major CEOs are now putting out SDG commitments. So as future business leaders, you need to be aware of sustainable development commitments and how forums like WSG is coming forward to coordinate the effort of organizations especially corporates, in becoming center of social sustainability and development. And finally, land settlement and planning. So this, you all know that it is almost impossible now to have a hydroelectric project in Kerala, because the land and resettlement impact of that is outweighing the benefits that we get from those projects. So that is a good example of how how engineering projects can change over the year. In the 1960s, Kerala was building so many dams. Some of the engineering wonders of India are there in Kerala in our dams. If you look at Mullaperiyar Dam, it is the oldest surviving lime surki gravity dam in the world. If you look at Idukki Dam, it was designed and constructed before all this advancement came, and it is still it is a wonder in how you use natural geometry to counteract the forces of nature. So we run through all the themes of the first emerging trend, which is sustainability. I am not looking at the chat window, so if there are any questions coming up, please, I request the moderator to stop me to look at it. Now we are going to look at the next emerging global trend, and this is on smart and new mobility. Now, this has come into India. The good example is Uber or Ola, Grab. These kind of mobility solutions. So let us look at those mobility solutions for a minute. I think India uses Uber, correct? So let us look at Uber for a minute and understand this trend. So we used to call a taxi standing in the road, or auto rickshaw standing in the road, And what Uber has done is that without having their own auto rickshaws or taxis, without having any single car, any single driver employed by them, they have become the biggest transport operator in the world by just using software. And they did not even create a new software. They took existing technologies and they stitched them together. And what they created newly was new user experience. So instead of waiting on a road with the uncertainty of what time I would get an auto or a taxi, who is going to be the driver? Am I going to be safe? What time would I reach my destination? How will I be charged? Is this guy going to, take me in rounds around the city? In one application, they removed all these uncertainties of user experience and created an experience that we can book something in advance. We can see where it is. We can see when it is coming to our doorsteps. So this is something that you have experienced in your lifetime. And I'm telling you, more of this is coming. So let us look at what are those trends. So the first trend is maybe a backward trend is this pandemic has now reduced the the travel zone of people. So currently we travel around the 2 kilometers of our home more than traveling longer distances, which was not the case earlier. So walking, cycling, and other micro mobility modes are becoming more popular. So it is possible that some of these trends would remain with more and more people working from home, students taking classes from home. It is possible that our transport infrastructure would need some change. Carpooling is becoming more and more easier with technology and that is currently happening in India. Mobility as a service, mobility on demand, this is becoming a very prominent trend. We talked about Grab, but we also now seeing trend where transport operators are putting sensors to measure their location of their trains, cars, buses, then providing that information publicly. It is made publicly available. Then digital entrepreneurs are building applications on top of them that users can use to avail mobility as a service. So if I want to go from A to B, I could maybe use an app that would then scout the mobility operators of my location and give me the best fit solution. So that trend is happening in Singapore. So you can connect maybe bicycles, you can connect bicycles to coming buses to trains. All this mode of transportations can be connected through information. The next substantial change that we are seeing is introduction of electric vehicles. When we looked at the carbon footprint of highways, it was very clear that if we can bring in electrical vehicles, our impact on this planet is going to be substantial. In your lifetime, you are going to see the death of fossil-driven propulsion, and you are going to see substantial adaptation of other kind of propulsion, especially electrical vehicles. All advanced economies have declared very bold initiatives to replace their vehicle populations with electrical vehicles. So what would this mean? This means that you need a new infrastructure. How would these vehicles park? How would they charge? It is not like filling petrol in 5-10 minutes. Electrical vehicles would have downtime for them to charge. They need to, and they need the charging infrastructure. They need to be available, in substantial quantities, in a substantial network. So that would involve a lot of engineering and planning. It will involve upgrading of our grids. Okay. Then comes fleet electrification. So we would see a substantial change in the mode of transportation, in the mode of propulsion, which means that all the fleets are going to change. KSRTC will move into electrical vehicles. You will find other, other fleets moving into electrical, ships would change into electrical mode, So that change is going to, you're going to see that change. We are also going to see a substantial involvement of other kind of fuel technologies. Hydrogen is currently coming up as a good alternative to alternative fuels. Currently, most of the sustainable electrical production is coming from solar and wind. It is possible that hydrogen could just wipe them off. That is the potential of hydrogen cells. So what would that mean? That means that we would have maybe substantial energy available for us to, or clean energy available for us to live in a different manner. Okay, let's come to now another emerging trend, which is connected vehicles and autonomous vehicles. So what is connected vehicles? So connected vehicles basically means that vehicles would have sensors which help them connect to intelligent transport systems and help drivers make decisions. Okay. Now, many of you would be in India paying using your phone. You can go to scanners, scan with your phone, and make payments. That kind of technology is available. So similarly, vehicles could have sensors which get scanned along their routes, and information exchange happens, which the vehicle itself or the driver could take decisions. This could actually combine with other things. For example, carpooling. So I step into a road, my mobile sends a signal to a nearby sensor, and that sensor sends a signal to the nearby network that has a car with one person seat available in the direction that I want to go, and tells the driver that, look, you need to make a stop here. This is possible. All right. Autonomous vehicles means the driver is taken out of this whole system. Currently, you are aware of Tesla making autonomous vehicles. In many campuses currently, we are seeing autonomous vehicles coming up in the National University of Singapore here. The internal traffic, we have autonomous vehicles. We also have autonomous vehicles delivering food these days. They are small buggies that travel from food shops to houses using GPS and using visual sensors to cross roads and deliver food and goods. Then we have digital twins. So what is a digital twin? So suppose I have, I was thinking of a good example for digital twin. So let us say we have a well that has water. Okay, so in a 3D model of this well, you will have the well wall, you will have the water, you will have the kappi and kair, everything that you have there, so you have all this modeled. So this is a 3D model of it. Now you could put intelligence into it, by including data related to all these things. Then you could build in sensors to it. Okay, so you could have a sensor that will tell you the water level inside that. It is not so difficult. It is possible these days. Okay, and then you have in your computer a model that is exactly displaying what is the water level, what is the yield in the well, what is the deflection of the walls, what is the precipitation happening and how the water level is changing. Is there a risk of flooding? During summer, what is the drawdown happening? You have, instead of going to a well and looking at it, you now have a digital twin that helps you have all this information in one place. Now, this is possible for buildings. This is possible for highways. This is possible for any engineering asset. All you require is very robust digital models and measurement systems that are linked together. So if you're doing an excavation, you can actually see how the walls move. You can have real-time measurements. You can have a geospatial model that helps you see all these things. So this is one very strong trend that we are seeing. The next is intelligent transport system, which is actually the network that binds all this together. Finally, we have new modes of mobility evolving. There are drones coming up which have the capability to deliver small payloads now. But remember, 5 years ago, there were no drones. So now we have drones that delivers stuff. So I think this technology would continue to evolve, which means that there will be new modes of mobility. There will be electric scooters. There are new forms of personal, you can have, you can have personal vehicles that would change the concept of transport. See, earlier in our fossil-driven propulsion, there was certain size of engine that dictated the size of vehicles. Now all you need is one wheel, one battery. And you see those kind of scooters here in the advanced economies. People stand on them, and they just take you for micro mobility mode. So these modes of mobility are evolving. So these are all trends that is happening in the transport space, and there are similar trends happening in Kerala as well. Kerala is trying to produce electrical vehicles. a lot of the technology related this is being currently looked upon in Kerala. Solar and other sustainable modes of fuels are being explored in a serious manner. And in India is one of the biggest producers of solar and wind power. There are a lot of projects. For Arcadis, one of our biggest businesses actually engineering services around solar and wind. So this is the second one. So what is the third emerging global trend? So this is maybe where I see a comprehensive impact happening, that is on digital transformation of construction. So earlier I had shared, my experience of how CAD changed, how analysis changed, but now we feel that technology has developed so much, and the pressure on the construction industry to change is substantial, that the whole digital transformation of construction industry will happen. It will happen in different measures, it will happen in different degrees, but it will surely happen. And in the next 30 years, when you ride your career, it is going to happen in a very transformative manner. So there are 10 areas of changes that we see. The first is prefabrication and modular construction. See, there was very little prefabrication happening in the 1990s. Where we stand now, we are seeing volumetric construction, where actually we build houses and stack them up. So using virtual design and construction tools, people can design. We can design homes. We can build them using 3D printing and additive manufacturing, or even normal casting technologies in lab. Finish it off and stack them off. It is happening. It is called volumetric construction. So that's one. The second is advanced building materials. So we are now, in the last, from 1960s itself, we are seeing evolving high strength materials, but now we are also seeing more sustainable materials with less carbon footprint, with more recycled materials coming in. The third is 3D printing and additive manufacturing. So this is a area where a lot of companies are now investing in technology. So whether they can use 3D printing and additive manufacturing to mass manufacture elements. For example, drainage channels, curbs, complex shapes and geometries, which is very difficult to cast, but smaller size. Those things are being currently researched, so that this trend will evolve. The fourth is autonomous construction. So, when COVID happened, Singapore managed to manage the COVID situation in a very professional manner. But our construction stopped because most of our workforce comes from countries that are impacted by COVID. So now companies are increasingly seeing the need to invest in autonomous construction, which means that, for instance, I know of companies that are investing in automatic or autonomous TBMs. So a TBM normally requires 30 people on a crew, on a shift. So if you have autonomous construction, where TBMs are intelligent and equipped with the technology and sensing that they can take decisions on their own, or can be monitored remotely, or using the fifth element, augmented reality and visualization, operators can operate it from somewhere else. Okay. Then the need for labors go down. In fact, Tesla is currently looking at technology where actually they could do tunneling at maybe 100 times the speed as what is being done now. Okay. The fifth part is augmented reality and visualization. So currently technology is available for us to bring in reality. For example, you can carry information with you in a phone that when you open your camera and look at a road, it will tell you using augmented reality where the utilities are. That kind of technology is being used a lot. Again, a trend that is emerging. Big data and predictive analytics. This is something very big that is coming up. So let me give you one example of an Arcadis project. So, we developed a system where for 2 years, we fed all the maintenance work that is happening on London Underground Rail, all their operating maintenance data was fed into a system. Okay, and then we started analyzing this data. We started using predictive techniques, artificial intelligence, to run different scenarios on why, whether we can see trends happening from this analysis. Can we model those trends? Can we bring in forecasting tools that helps predict? And at the end of all these exercises, we created a result that by spending 50% of the budget, you can achieve 90% of the result. So by focused spend, we created a result that by focusing the spending on where it matters, we are able to save a lot. We are able to create the same result, but save a lot. Okay, so this is where big data and predictive analytics is becoming important. Wireless monitoring connected equipment. Now, this is a very obvious technology that is developing. For instance, if you look at this shape here, this the excavators. Okay, so there is a company in called Kobe. Kobe produces excavators, and they supply a lot of excavators to India, and they installed sensors in their excavators. Okay, and their primary intention was to, I think they spend around 5,000 rupees to install a sensor and a transmitter to just monitor how long a excavator keeps working, how long it is operational. So what then they did is they used this information to predict when would they require maintenance. So they know that, okay, this particular bearing needs to be replaced after 3,000 hours of operation. Okay, so they could move this this spare parts to the location of that market and keep it ready, that when the servicing comes up, they're able to service it fast. So they were able to offer operational and maintenance contract to owners very efficiently. So apart from sales, they also then monetized operation and maintenance. Then they could also do something else. When they looked at that data, they found that most of the excavators operate only 60% of their time. 40% they are free. So they went to the owners and told them that, look, now we have a platform where we can aggregate demand. And if you become part of that platform, we take 20% of the revenue and the remaining 80% is yours. And that is, dead money, dead time that you are monetizing it. And it was a win-win for all parties. So there, you can see how technology, a simple technology, can change the way business is done. All right. 8, cloud and real-time collaboration. I'm not going to talk much about this because this is exactly what we are doing now. We are collaborating on an interaction here. 3D scanning and photogrammetry. So, we will move more and more into the digital space, and for that, it is very important that current assets are converted into 3D assets or 3D digital models. And currently, a lot of technologies are being developed for 3D scanning and photogrammetry. If I could give you one example, I know that a simple tool is there in Kerala that you can take a photograph in a phone and send to the PWD minister. They can geomap it and they can fix the pothole in the road. In Singapore also we are using something similar. We are having cameras that are fitted on vehicles that scan the surface of pavements. They have 3D scanners. They do, there is programs built into it that can assess the pavements. There are algorithms built inside that can assess, look, is there a defect that needs a rectification? If yes, then a work order directly goes to the contractor, and the contractor is given the geotag of that location, and all this is automated. So this is again an example how technology changes things. So at the heart of all this, the backbone of all this digital transformation is BIM, building information modeling. Okay, so BIM has been a technology that is developed along the last 10 years and now is becoming the backbone of how digital transformation of our industry is going to happen. So this is the third, the third trend that is emerging. So if we look at how this trend would mean in near-term opportunities, okay. So I think this COVID has created some global changes. One of that is that across the world we are seeing nationalism popping up and immigration control coming, which means that when I graduated in the 1990s, it was an open world. We could travel to most of the countries. We could do work in most of the countries. There was very little limitations other than your ambitions. Okay, but that is not the case now. A lot of borders are being closed, not just because of COVID, but because also the economical impact of COVID is making markets turn inwards. Okay, so that is the challenge. But the opportunity is that it means that work can come to you. So there will be more offshoring of work coming into engineering centers like India, and that is going to open up opportunities for all of you. So in India, what we see is that there is a competition between states for infrastructure investments. And we have to be mindful that Kerala is only 3% of our population. We are not a major factor in India. So the major factor are the big, the big states, especially, Karnataka, Tamil Nadu, Maharashtra, Gujarat, Rajasthan, Uttar Pradesh. These are the big states where infrastructure investments are going to be more focused. Kerala is realizing this, and that's why we have set up mechanisms like KIFBI to make our investments in infrastructure move forward rather than become stagnant. But this is something that you got to keep in mind, because if you need to go outside, if you need to grow, very likely you may have to go outside Kerala, and you need to have the skills for that. Construction would continue to be the fastest growing industry, but it is the second lowest in productivity. Yeah? The lowest productive industry globally is hunting. So the way people have been hunting 100 years ago still remains the same. It's the same. Huh? They got to pick up a gun, aim, and shoot. The second is civil engineering. So that is where we stand. So that is it's a sad fact, but that also shows immense opportunity for us to, show improvement in productivity. India needs a large number of civil engineers, and our current production is not enough. So most of you should not find difficulty in getting a job if you are willing to go to the places where the job exists. But employability remains a big concern. I had a session with Dr. Sreekanth many years ago. I asked him what is his biggest challenge. He told me it is finding skilled people. He told me that only 8% in India's graduates are employable. 12% are employable with more training. So roughly 20% is what is employable. The remaining workforce is not even fit for employing in 1 or 2 levels down. And this is something that you got to keep in your mind. Finally, in Kerala, there is going to be a reduction in remittance, which means the nature of our economy is going to change. There is going to be more increased production locally. There is going to be more increased investments by the government. More work would come to centers like, the technoparks. More engineering work would come there. I'm aware of BIM work currently happening in our technoparks. Engineering work happening in technoparks. Given Kerala's coastal lines, our Western Ghats, and the exposure that we have to rain, climatic and the lowlands that we have. Climatic adaptation is going to be an important part of the engineering future for us. So prepare for it. Apart from that, then, yeah, there is going to be the operation and maintenance part. I would also request you to keep this picture in your mind. Okay, this shows the volume and profit of engineering business. Okay, so the length shows the volume, the depth shows the profit. Generally, a lot of work on feasibility, the volume is less, but it is the most profitable segment. Design and engineering comes after. PM and supervision, there is large volume, but is generally lesser profit. Maintenance, upgrading, and decommissioning, there is also a large volume, and again the profit is moderate. Okay. When digital disruption comes into this, these matrices could change. So as engineers, when you look into this 30 years, I think that there are three kind of skills that are going to be important. One is technical skill. So technical skill would remain core to what you do. In having the right design skills or project management skills or environmental and sustainability skills, whatever it may be. Your expertise as a technical as a technical expert would matter. If you desire a career in engineering, but along with that, you need to have digital skills. And if you don't know these words, what these words means, then I am warning you. You got to be careful. BIM is building information modeling. VDC is virtual design and construction. IDD is integrated design delivery. These are the established trends that are now growing to move leaps in the way that we do business. I also would want you to go and look at Arcadis job sites. You will be surprised to find that an engineering consultancy like Arcadis, most of the positions that we ask for, we are now looking for analytical and scripting skills. We want engineers who know data analytics, who know Python, how to write scripts, So along with your technical skills, digital skills are also becoming important. Ecosystem knowledge. So most, as geotechnical engineers, you might use different softwares, but now you need to understand how you can, for example, write a Python script that could work in the ecosystem of Plexus and create a parametric design for your tunnels. These elements of parametric design and this is becoming and repetitive design is becoming very important in this ecosystem. Then soft skills. This is one part engineers fall back substantially. Maybe it is the nature of our training, because it is the nature of our industry. We are always focused on details. We dig deeper, into details. That's the nature of our trade. But develops soft skills, very good verbal and written communications. If I have to choose one skill that helps you after a certain level, it is verbal and written communication. Okay, it is this soft skill package. Okay, next is adaptability. So you need to be very adaptable. Okay, those who are more rigid in what they do, I think they are going to have lesser choices, because the world is going to be like that. The digital disruption, the challenges that is coming on various fronts of sustainability, technology. These are going to require professionals to have large degree of adaptability. And the third skill is commercial acumen. You need to know how to make money in your business. Not to make for yourself, just not to make yourself alone. That is also important, very important. But also how businesses make money. That's very important for you to understand. Okay. So major opportunities in next 5 years, a quick brush through. I think globally, there will be a lot of demand on engineering skills. So if you are in India, infrastructure skills, digital skills, communication skills, competency in the international score. These would be things that you would look for. Climate adaptation skills, I think, would be good. Hydrodynamic modeling, drainage engineering, coastal and offshore engineering, general civil engineering. Mobility is going to require more transport planning, modeling, EAV capabilities, logistic capabilities, then the general digital and general skills that I talked about. In India, you see, India is an economy that would grow. Whether there is COVID, whether there is, typhoon, floods, India's general direction would be one of growth. Okay, and that means that there will be infrastructural growth. So all these items here, there will be areas of growth. For Kerala, it is going to be a bit more sustainable model of development. So you would see more elements of climatic adaptation, agri-business, this kind of dimensions coming into the development in Kerala. So these are some of the big projects that is coming up that would throw up demands. And hopefully Kerala will also be able to ride. We have been one of the best performing GDPs in India. We are number one in sustainable development in India. So hopefully these would give Kerala an upper hand, an advantage in the next phase of our development. So thank you very much. This has been the message that I wanted to put across. And I would stop now here to take questions.
Thank you, sir, for your valuable information. Now, the session is open for asking doubts and queries. Please feel free to ask your queries. You may also use the chat box for asking the doubts.
Yeah, good evening, sir. Sir, can you tell us the challenges that faced while working on a sustainability project and how these challenges are overcome?
I think let me. Okay, so let me take the example of any project, not just a sustainability project. Let us take any project and see how sustainability becomes challenging in that. Okay. The high-speed rail project in India, right? Okay. So it involves running a railway line for around 500 kilometers. Okay. And Arcadis is doing the social and societal impact studies for this project. Okay. So the challenges we face is that fortunately we have a client that understand this impact very well, that they at the feasibility study itself, along with engineering design, they wanted these studies to be done, understand it carefully. And when this project is being implemented on ground, okay, there are a lot of challenges. Okay, when you try to acquire land, when you try to displace people, the alignment for a high-speed rail in India, if you ask me, had to depend a lot on how it impacts people rather than how the most efficient way the train runs. Okay, so if I could sum up the challenges, it is about maybe one, establishing the bankable case, whether it is worth investing or not. The second is how do you understand the impacts? How do you develop a methodology to mitigate it? The third is how do you sell it to stakeholders? And the most important stakeholders would be people who are impacted by the project. Did I answer you sufficiently?
Thank you, sir.
Any more queries from participant side?
Sir, we need to consider the full harmony of both ecological as well as economical development. So for this, is that sustainable development possible, and mainly for this underdeveloped, developed and developing countries? is it possible to maintain that harmony?
So the first question is there a choice? So the trends tell us that there is no choice. So it is about when, how, and how much. So for developed economies, they are able to make the investments much more substantially and maybe in a much more organized manner than developing economies. So for instance, I showed you the map of Singapore. So this year Singapore is starting the hydrodynamic modeling studies for protecting the Singapore coastlines. Substantially big project. It is starting this year. So to answer your question, one, I think that there is no choice; it has to be done. Otherwise, the quality of life would continuously be impacted, and people will find that their quality of life goes down. So I think that will lead to a lot of social displeasure and unrest. The second is then, how would engineers hold hands with economists, with policymakers? And so when you all grow into different roles in your career, please, carry this message with you that that you would be part of that decision making, and you have to consider this increasingly. I don't know how much of this currently is in your curriculum, maybe not much, but increasingly you will find that this would come into your practice.
Thank you, sir.
Sir, there is a question in the chat box. I will read it for you, sir. In your first carbon footprint slide, what does the title of vertical axis T carbon dioxide mean?
So T carbon dioxide is basically tons of carbon dioxide, but I think what matters is that scale. You saw the scale, right?
Okay, thank you, sir. So now the session is open for sharing the feedback from the students.
So we talked about your future. So I'm happy to listen to you. How relevant you feel. You don't have to be overwhelmed that this came from me, because we are all looking at the future with the same crystal ball. Maybe I have a bit of advantage of more experience, but otherwise we are all looking at it with the same uncertainties, in the same with the crystal ball in our hand. So yeah, feel free to have your opinion, however diverse it is from mine.
Sir, the session was very informative. Thank you so much, sir, for your time and valuable words. Thank you so much, sir.
Sir, it was a very nice presentation and such an informative session. Thank you, Sreekanth sir, for spending your valuable time with us.
Sir, it was a very important career development information you delivered, and a very valuable guidance, and a wonderful experience too. And you kept the session lively. It was very useful and very interesting for us. Thank you, sir.
Thank you, sir, for this enlightening section. And this was a really informative session for us. Thank you, sir.
Okay. Once again, I thank you, sir, for the interesting session.
So I have one question to ask.
Yes, sir, sure.
So how many of you in this group think that this is not relevant? That these trends, do you see these trends in your, from where you are now? Do you see these trends?
Hi, Sreekanth. Vino from C3.
Hey, Vino, what a pleasant surprise.
Yeah. This talk was a really interesting one. And from my vantage point, everything that you said is true. I have also the same number of years of experience just as you, 30 years. We graduated the same year. And I see that digital trends is one of the biggest shifts. And mobility is changing. I think modes of mobility like Hyperloop and other mass transit, high speed. Also the fact that tele-mobility has become vastly accepted due to the pandemic as it reshapes the business world. So I think that's a huge impact on how we will see the carbon footprint development for the future.
Yeah, I think that's a very interesting point. One of the things that COVID has done is that it has changed the travel patterns completely. So, for instance, countries that were planning to invest a lot on transport infrastructure, on spine infrastructure, on big highways, on big rail networks, urban networks, they are currently rethinking whether that investment should be made around the neighborhood to enhance, people's ability to cycle, more active mobility, more. Maybe for mid distances come out with electrical scooter facilities and stuff like that. So yeah, I think we are seeing disruptive technologies and trends on both side of that transport spectrum, on things like Hyperloop at this as well as on the other side.
Yeah, I agree. Thank you very much. It was a very informative talk.
Yeah, and really pleased to see you here. I did, note when that question came up, I did notice that there is this name, and it is similar to your name, but I never thought that you were there. But it was very kind of you to attend this.
Yes, Sreekanth, this is Roji, another one from C3.
Oh my God!
Yeah.
Hello, Roji. Such a pleasure to meet you here.
Yeah, so I was listening like what you're saying about the programming. Like we have the basic program. I know like Dr. Ruby Abraham, she did that class. I know like I mean nothing personal, but like I think she was put on a position like to teach the class, and she has no clue what she's doing. And I don't think so. We never learned anything from that course. Like that was probably like just the basic language, and see like how the technology changed from we graduated and now like. Yeah, so my project was also like some kind of for this MTech. It was also finance FEM. So I did something FEM. I think like there's one software in the lab, and I copy that. And the project was like kind of like in between that software analysis and did a lab test on the lab. So it was like a total big change from the 30 years.
Yeah, very, very true. And maybe, I should also request you to switch on your camera that I can see you after many years.
You should be shocked. You should be shocked.
What I remember is that the number of hours that we spend on a computer language in our education, compare it to the number of hours that we spend on a workshop doing foundry, carpentry. So it shows how much the skill sets are changing, and it is going to be more substantial for the next generation.
Yeah, it means they will not like they cannot digest like I think like when I was doing the MTech, that's the time the first email came out. I think like in 1995 or 1996. Before that, there was no email. So now it's like an email, WhatsApp. It's everything. like a totally different change.
Yes. All right.
All right,
Yeah,
and
very
nice to see you. Yeah,
Nice
I'm
to
going
see
to
you.
leave because I need to run for something. All right, see you. Bye.
Thank you, sir. Now I welcome Anjima from MTech to propose the vote of thanks.
A warm good evening to one and all. It's a great honor and privilege for me to express vote of thanks for today's session. First and foremost, let me thank our special guest and speaker of the day, Mr. Sreekanth sir, for this wonderful session. The presentation was an enlightening and informative one, and I'm sure that the knowledge you shared will definitely benefit us in our future. Thank you, sir. I express my deep sense of gratitude towards our management, head of the department, faculties, and mentors of our chapter for their encouragement and great support. I express my gratitude towards the organizing team for the great effort in making this event a grand success. On behalf of entire IGS student chapter of Marine Engineering College, we thank each and everyone who participated in this session. Last but not the least, let me thank the God Almighty for making this webinar a grand success. Once again, thanking you all. Thank you.
Thank you, Anjima.
Thank you, everyone.
Now we have a virtual memento as a token of gratitude. Can we have it on the screen, please? This is presented to Sreekanth APV with deep appreciation for your visionary guidance and in recognition for your enduring commitment throughout this webinar. We thank you for spending your valuable time with us. Thank you, sir.
Thank you very much. Great pleasure to be with all of you, and my regards to Dr. Narayanan as well. And I wish that all of you stay safe and take all precautions against COVID and stay in good health. All right. Have a good weekend. Bye.
Participants, please note the feedback form is provided in the chat box. Please ensure that you fill it without any fail. Thank you once again, all the participants and faculties who joined with us on this webinar. Thank you all.